The breath of life. In previous discussion with regard to the cosmos, it was stated that mankind could be described as the microcosmos, and organic life on Earth as the tritocosmos. Then it was further pointed out that each cosmos experiences time in a different manner, or on a different scale, which can be associated with breath. A sparrow, for example, breathes at a different rate to a whale, where in that context each unit of breath would be equivalent to a unit of time. A human being in a normal state takes about 20 full breaths, that is inhalations and exhalations, to the minute. A full breath therefore takes about 3 seconds. Sleep and waking are therefore regarded as the breath of organic life on Earth, where for a person, and for all organisms living in similar conditions to us, even for plants, a full breath is represented by a 24-hour cycle. Sleep and waking are in this manner regarded as breathing for organic life, because plants when asleep, that is at night, exhale, and when they are awake, which is during the day, they inhale. In exactly the same way for all mammals, as well as for Homo sapiens, there is a difference in the absorption of oxygen and CO2 by night and by day, in sleep and in waking. Reasoning thus, it would be logical to arrange the periods, or cycles of breath, and of sleep and waking, in the following manner. Applying a simple rule of 3, we could divide 24 hours by 3 seconds, giving 28,800. Then by dividing 28,800 day and night cycles by 365 we get close to 79 years, which represents the lifetime of the average human being. This parallel could be continued further. Again, multiplying 79 years by 30,000, rounding it up, we get a little less than 2.5 million years. Then multiplying 2,500,000 years by 30,000, we get a number of 11 figures or 75 billion years. So far, these figures appear to be logically possible with 2.5 million years for organic life on Earth, and 75 billion years for the planet itself. However, later there are cosmoses lower than man, so let's examine how they stand in relation to this. Taking 2 cosmoses to the left side from the microcosm, and understanding by them first, comparatively large microscopic cells, and then secondly smaller, admissible, almost invisible particles. Such a division of microorganisms into 2 categories cannot be said to be accepted by science. However, if we think of dimensions within the micro-world, then it is impossible not to accept that this realm consists of 2 worlds, as distinct in themselves as the world of people and comparatively large microorganisms. 24 hours would then represent the life cycle of such a cell, and although the period of life of an individual cell can in no way be considered as established, science has revealed that for a specialized cell, such as those in the human organism, the period of life appears to be approximately 24 hours. The breath of a cell such as this would then equal to 3 seconds, which tells us nothing yet. However, the 3-second lifespan of such a particle tells us a great deal, and it indicates above all why it is so difficult to observe these particles, although by their size, they should be accessible to view with a good microscope. Working with these numbers further, we see what would happen if we took breath, that is 3 seconds, and then divided it further by 30,000, giving 1/10,000th part of a second, the period of duration of an electric spark, and at the same time the period of the shortest visual impression. For convenience in calculating, and for clarity, 30,000 is taken instead of 28,800, and the coefficient rounded up. For periods then appear to be connected with, or separated from one another, by 1 and the same coefficient of 30,000. The shortest visual impression. Breath or period of inhalation and exhalation. A period of sleep and waking. The average lifespan. At the same time, each of these periods appears to denote a corresponding but lower period in a higher cosmos, and a corresponding but higher period in a lower cosmos. Taking this further, we can attempt to make a fuller table, and bring into it all the cosmoses, to add 2 more of the lower ones. The first of which is a molecule and the second an electron. Then again, for clarity, when multiplying by 30,000, we can take only round numbers, and only 2 coefficients, 3 and 9. Thus 2,500,000 is taken as 3 million, 75 billion is taken as 90 billion, then 79 as 80, and so on. The coefficient of 30,000 may appear too big, but at the same time remember that the relation of one cosmos to another is as 0 to infinity, and in the presence of such a relation, no coefficient could be too large. The relation of 0 to infinity is the relation of magnitudes of different dimensions. Every cosmos is three-dimensional for itself, which means that the next cosmos above it is four-dimensional for it, and the one below is two-dimensional. The next one above that, five-dimensional, and the next one lower, one-dimensional. One cosmos in relation to another is a magnitude of a greater or a smaller number of dimensions. However, there can only be 6 dimensions, or with 0, 7, but by this table 11 cosmoses are obtained. At first glance this appears strange, but only at first glance, because as soon as you take into account the period of existence of any cosmos in relation to higher cosmoses, then the lower cosmoses disappear, long before reaching the 7th dimension. Take for example man in relation to the sun. The sun appears as the 4th cosmos in relation to man, taking man as the 1st cosmos. However, man's long life of 80 years is equal in time to one electric spark for the sun, one shortest possible visual impression. Each cosmos is an animate and intelligent being. Each cosmos is born, it lives, and then it dies. In one cosmos it is impossible to understand all the laws of the universe, however 3 cosmoses taken together include in themselves all the laws of the universe. Or 2 cosmoses, the one above and the one below, are determined the cosmos that lies between them. By passing in his consciousness to the level of a higher cosmos, a man, by this very fact, passes to a level of a lower cosmos. Here in each word lies a clue to the understanding of the structure of the world, however there are yet many clues to grasp. How then does movement from one cosmos to another appear, then where or when does the movement disappear? In what relation would the figures stated in the table illustrated stand to the more or less established figures of cosmic movement? As for example the speed of movement of the heavenly bodies, the speed of movement of electrons in an atom, or the speed of light and so on. When you begin to compare the movements of various cosmoses, you get some surprising correlations. For example, for Earth the 24-hour period of the rotation on its axis is equivalent to 1/10,000th of a second, for man that is the speed of an electric spark. It is doubtful therefore whether at such a speed, the Earth would notice the rotation on its axis. If man rotated similarly, then rotation around the Sun would occupy about 1/25th of a second, the speed of a still photograph. Taking into consideration the enormous distance that the Earth has had to traverse in this time, the inevitable inference is that the Earth could not be conscious of itself as we know it, that is, in the form of a sphere, but that it must be conscious of itself as a ring, or as a long spiral of rings, the helical model of our solar system as a vortex. The latter is the more probable, using a definition of the word present, as the time it takes to draw one breath, which is what comes to mind when time is defined as breath. Starting from this, we could say that breath may be regarded as a unit of time, that is to say for direct sensation, the period of one breath is felt or perceived, as the present. Suppose then that the sensation of self, which is of course one's body, is connected with the sensation of the present, then we come to the conclusion that for the Earth, with one breath in 80 years, the sensation of itself should be associated with 80 rings of a spiral, circumnavigating the Sun. Passing to the lower cosmoses, to the cosmoses in the table that stand to the left of man, we see in the first of them an explanation of what appears to be the astonishing speed, almost instantaneous, with which some of the inner processes of our organism work. Someone who gives thought to questions of physiology may not be astonished by the fact that the effects of drinking a cup of coffee or a glass of brandy, the inhaling of the smoke from a cigarette, can be felt immediately throughout their entire body, changing all the inner correlation of forces and the form or nature of reactions. It ought to be clear to such a physiologist that during this quite imperceptible interval of time, approximately equal to one breath, a long series of complicated chemical and other processes are accomplished within their organism. The substance that has entered the organism is carefully analyzed, the smallest divergence from the usual is immediately sensed, and in the process of analysis it passes through a series of laboratories. It is resolved into its component parts and mixed with other substances, then in the form of these compounds it is added to the fuel that nourishes our various nerve centers. All of this must occupy a great deal of time. The seconds, in our time scale, during which all of this is accomplished, make it a fantastic and miraculous phenomenon. However, the fantastic falls away when we realize that for the large cells that obviously govern the life of an organism, our one breath continues for over 24 hours. In 24 hours, even in half the time or a third, 8 hours, which is equal to 1 second, it is possible to imagine all the processes that have been indicated being accomplished in an orderly manner, exactly as they would be in a large and well-arranged biochemical facility with various laboratories at its service. Passing on to the cosmoses of small cells that stand at the border, or beyond the border of microscopic vision, we again see an explanation for the inexplicable. For example, cases of almost instantaneous infection by epidemic, and infectious diseases in general, particularly those where the causes responsible for an infection have not been found. If 3 seconds is the limit of life for a small cell of this kind, and equal in proportion to the long life of man, then what would be the speed at which these cells multiply, when for them 15 seconds would be the equivalent of 4 centuries? Moving to the world of molecules, we come face to face with the fact that within the brevity of the existence of a molecule lies an almost unexpected idea. It is usually supposed that a molecule, although structurally very complicated, when taken as the basic, the living interior of building blocks from which matter is built up, existing for as long as that matter exists. We are however obliged to part from this comforting thought. The molecule that is alive inside cannot be dead outside, and in remaining alive, it must, like everything living, be born living and then die. The term of its life equal on our scale, to an electric spark, or to 1/10,000th part of a second, is too small for it to act directly on our imagination. So some comparison, some analogy is necessary, in order to understand what this means. The dying cells of our organism and their replacement by others, bring us near to the idea. Dead matter, such as iron, copper and other minerals, must be renewed from within more quickly than our organism perceives. In reality it changes before our very eyes. If we look at a stone, shut our eyes and immediately open them again, it will not be the same stone that was previously seen. Inside of it, not one single molecule that we saw the first time would now remain. Furthermore, even then, we did not see the molecules themselves, but only their traces. Then in the last cosmos, that is in the world of an electron, we can sense from the very beginning, the world of the 6th dimension. An electron, as a 3-dimensional body, is too unsatisfactory, as to begin with it exists for 1/300 millionth part of a second. That is a quantity far beyond the limits of our possible imagination. It is considered that an electron within an atom moves in its orbit with the speed of 1 divided by a 15-figure number. Since the whole life of an electron, in seconds, is equal to 1 divided by a 9-figure number, then it follows that during its lifetime, an electron makes a number of revolutions around its sun, equal to a 6-figure, or taking into account the coefficient, a 7-figure number. If we take the Earth in its revolution around the sun, then according to the table shown, it makes, in the course of its lifetime, a number of revolutions around the sun equal to an 11-figure number. It looks as though there is an enormous difference between a 7-figure and an 11-figure number. However, if we compare with an electron, not the Earth, but the planet Neptune instead, then the difference will be considerably less. Namely, the difference between a 7-figure and a 9-figure number, that is a 2-figure difference instead of 4. Aside from this, the speed of revolution of an electron within an atom is a very approximate quantity. It should be remembered that the difference in the periods of revolution of the planets around the Sun in our solar system represents a 3-figure number, because Mercury revolves 460 times faster than Neptune. The relation of the life of an electron to our perception appears thus. Our quickest visual perception is equal to 1/10,000th of a second, an electric spark. The existence of an electron is equal to 1/30,000th of 1/10,000th of a second, that is to 1/300 millionth part of a second. In that time frame, it makes 7 million revolutions around a proton. Consequently, even if we were to see an electron as a flash in 1/10,000th of a second, we would not see that electron in the strictest sense of the word, but only the trace of an electron, consisting of 7 million revolutions multiplied by 30,000, that is a spiral with a 13-figure number of rings. Expressed in the language of the new model of the universe, this would represent 30,000 recurrences of the electron in eternity.